For this one, a gaseous mixture containing 5.9 moles of argon and 7 moles of carbon dioxide has a total pressure of 8.4 atmospheres. What is the partial pressure of CO2? So the way this works, there's a couple equations that come up. So the total pressure equals the partial pressures of argon and the partial plus the partial pressure of CO2. And then one other thing that we need is that the partial pressure is equal to the mole fraction times the total pressure, and that's a P. My P's sometimes look like D's. I'm sorry about that. Now, and this idea of a mole fraction, so fractions I think we're relatively used to. A mole fraction is just going to be, so let's do the mole fraction of carbon dioxide in this case. That's just going to be the moles of carbon dioxide over the total moles. And we know what our moles of carbon dioxide are. We can add up our total moles. And we get a mole fraction, 7 divided by 5.9 plus 7, or 12.9. I get 0.543. And now my partial pressure of carbon dioxide is going to be equal to my mole fraction of carbon dioxide times total pressure. And my total pressure is 8.4 atmospheres. Multiplying this out, 0.543 times 8.4. I get 4.56 atmospheres. And the reason this question is important, or when I think about this process, what it calls to mind is that whenever there's two gases, those two gases are both colliding with the walls of the container, and regardless of their size, so argon has a molar mass, oh boy, I'm gonna have to find my periodic table now amongst all this stuff. There it is. Argon has a molar mass of 39.95. grams per mole, and it's going to collide with the wall. And carbon dioxide, which for now we might draw like this, carbon with 2 oxygens around it, has a molar mass of 44.01, and it's going to collide with the wall. And even though they have different molar masses, they will, each molecule exerts the same pressure. And the only thing that matters as part of the total pressure is how many moles of each. And I guess another way of saying that is pressure is proportional to moles. And even though the argon is lighter, which would tend to make it have less pressure on the walls, it's moving faster, and those two effects exactly cancel out. Any questions about this? So the answer is right here. And while it doesn't say it, you do want to put your units in as atmospheres, which I think is not stated, but hopefully pretty clear anyway. Any questions?